practice 8 for section 4.8. In exercises 1 through 4, we're going to use the diagram. Copy and complete this statement. Tell what theorem or corollary you used. So here's a diagram, and there's a lot of triangles in here if you don't realize it. The best thing to do to make the diagram simpler is to redraw it. So we're looking for segment AE to be congruent to segment CE. So that's this guy and this guy. So I'm just redrawing this small little triangle right here, triangle AEC. And I knew to redraw that triangle because that gives me two congruent sides, this statement, on this one triangle. So we have an isosceles triangle theorem that tells you that if the legs are congruent, then the base angles are congruent. So which angles would be the base angles? Well, if these are the legs, then this is the base. And if this is the base, the angles that touch the base are the base angles. So your answer to number 1 is angle A needs to be congruent to angle C. Number 3, we have 3 congruent angles. So we need to draw a triangle that has these 3 angles in it, or a diagram with these 3 angles in it. So angle BDF, that's this one. Angle DBF is this one. And angle BFD is this one. So basically, this probably isn't a good idea if you're doing all 4 problems, but if you're just doing a couple, you can probably make marks on that little triangle and not really kind of mess yourself up for the rest of them. If these 3 angles are congruent, what kind of triangle is this? Well, this would be an equiangular triangle. And we have a corollary that says if your triangle is equiangular, then it's also equilateral. So that means segment BD is congruent to segment BF, and that's also congruent to segment DF. If all of the angles are the same, then all the sides are the same. That's what that corollary says. Now, numbers 2 and 4 are basically the same thing. You might use the converse of the isosceles triangle theorem, or the converse of that corollary. In number 5, let's find the unknown measure. This triangle is equiangular, so what that means is it's also equilateral. So all 3 sides are congruent, so if one side is 6, the other sides are 6. In number 6, you have an isosceles triangle. These 2 sides are congruent. If these are congruent, then those are the legs. That means this is the base. And if this is the base, we know the base angles are congruent. So if that angle is 70, this angle is 70 as well. Now, they didn't ask you to do this, but you could. 70 and 70 adds up to 140. You have 40 degrees left for your vertex angle. So we didn't have to do it here, but you're eventually going to have to do it. So when that's time, you've already done an easier problem. Number 9, find the value of x. So these 2 angles are 60. That means these are base angles. So these legs are congruent. That's what that means. You have 2 congruent angles, so you're going to have 2 congruent sides. Now, if you want to go a little bit further into this problem, if these 2 angles are 60, this third angle must be 60 as well. 60, 60, 60. That makes an equiangular triangle, which is also equilateral. So if that's 7, that's 7, and we're talking about segment lengths now. That's 7. This segment has a length of 7 as well. So what you're doing is you're writing an equation. 2 times a number minus 3 gives you 7. Well, if you add 3 to both sides, you get 2 times the number is 10, so x is 5. And that's how you're going to do all the problems in this section. So if you look at this one, number 11, clearly these 2 angles are the same. These are base angles. The base angles are congruent. So that means the base, which has a length of 20, is not the same as these legs. But these 2 legs are the same as each other. So if this one's 28, this one's 28. So we're writing an equation. 9 times a number minus 8 equals 28. This expression must equal 28. Add 8 to both sides. divide by 4, divide by 9, and you get 4. Okay, so step 1, just classify the triangle. That way you know what is the same in the triangle, and then you can write an equation. Number 13, these two sides are congruent. That means the triangle is isosceles. It could be equilateral, but it's definitely isosceles. So if these are the legs, then these are the base angles. And we don't know what these base angles are, but we know they're the same. Now I know these are angles because notice the degrees. See the unit? So I know 7 times x plus 5 and x plus 47. Those two angles are base angles. I know they're the same. You need to write an equation first. We're going to subtract x from both sides. We're going to subtract 5 from both sides. And divide by 6.